So you guys should have 3.1. It's our exponential functions. We're just calling it part 2 because I didn't get through everything. We talked about exponential functions, seems like 6 weeks ago when I saw you, but on Friday, how their domain was always negative infinity to positive infinity. They had a horizontal asymptote that they get really, really close to but don't touch. That's the vertical shift. You could shift them left and right by doing things to the exponent. You can flip them over axes by negatives being in different spots, that sort of a thing. So today we're going to talk about something called solving, the one-to-one property. We're going to be using our calculators, using the E to the X button, and we're going to talk about compound interest. So your quiz on Tuesday is going to be 2 parts. It's not long, but you're going to have one part that you can use your calculator and one part that you cannot use your calculator. It's important if you don't have a calculator here with you today that you bring one tomorrow, whether it be something that you borrow from someone or something that you have at home. You have to be able to use your calculator because I'm not going to help you troubleshoot the day of the test or quiz. So it's important that you guys know how to use the calculator that you have in your possession at whatever time. Okay, so we're going to talk today about solving using the one-to-one property. All right, this first statement, for when a is greater than 0 and a does not equal 1, a to the x equals a to the y if and only if x equals y. All right, look at this right here. What do you notice about this equation right here? Same base. The bases are the same. Bases are same. When the bases are the same, you can cross them out and set the exponents equal to 0. No, equal to each other, sorry. I was looking at the next thing I wanted to say. Equal to each other. All right, we're going to solve all sorts of logarithmic and exponential problems. We're going to start that 3/4, 3/3, 3/4. But when you are asked to solve using the one-to-one property, this right here tells you all the information you need to know. It means you'll be able to mathematically get the bases to be the same. Then you can cross them off and set the exponents equal to each other. Another major thing you need to remember is that anything raised to the 0 power equals 1, correct? Very, very important to remember. Anything raised to 0 power equals 1. So if you look at this these sets of problems, it says using the one-to-one property. I just told you, one-to-one property means somehow, mathematically, I can get the bases to be the same. So if I look at A, 3 to the x minus 2 equals 9. What are the bases in these problems? 3 and 9. All right, we want to get those bases to be the same. I cannot break 3 down anymore, so I'm just going to leave that as 3 to the x minus 2. What is another way that I could write 9? 3 squared. Everybody agree? I did not change the value here at all. I changed the way it looks, but I did not change the value. 9 is the same as 3 squared. Now that the bases are the same, you can solve using the one-to-one property. Cross off the base, set the exponents equal to each other. You would add 2 to both sides, and x equals what? 4. Perfect. The beauty of getting x equals something is you can do what to check your answer? Plug it back in. Whether it's a fraction or not, something like that, whatever, you can always plug back in. Look, if I put a 4 right here, what's 4 minus 2? What's 3 squared? 9. So it works. Look at B. All right, now you're like, okay, then you go and throw in a fraction. Think about this for a second, guys. This is 2 to the first power down here, right? Yeah? You guys agree? We don't like fractions. So what could I do with this 2? If I moved it up here, how could I rewrite that? 2 to the power of negative 1. Good, and I still have that x. When you have a fraction, move the denominator up. All that does to our exponent is change it to a negative. Now my base here is 2. What could I use as a base for 16? And what would the exponent be if I used a 2? 2 to the what power gives me 16? 4th power. I did not change the value here. I just changed the way it looks. 16 is the same as 2 to the 4th power. If I give you one of these problems, you can make it work. So you might have to think a little bit, but you guys can make it work. Now that my bases are the same, I cross them off. So I have negative x equals 4. So what's my answer? X equals negative 4. Perfect. If I plug that in up here, whoops, not negative 16, negative 4, right? We distribute to the numerator and to the denominator. If I have 1 over 2 to the negative 4th, my negative to become a positive would move up to the 4th equals 16. Good to go. Anytime you have a fraction, just move the denominator up. Make the exponent negative. What about here? Some people were stumped on this. Can you change 6 into the base of 1 or 1 into the base of 6? No. But if you just say this out loud, 6 to what power equals 1? 0. X equals 0. Just say the problem out loud, and the answer is apparent. 6 to what power equals 0? The only thing that you could raise any number to make it a 1 is a 0, unless it's a 1. So that's your one-to-one property. You're going to have a couple of those. We're going to practice more, I promise. But it's important that you guys understand one-to-one means, oh, I can get the bases to be the same mathematically somehow, and then you can solve. All right, scooting along. Now we're going to talk about natural base E. All right, there's something called the natural base E. This is the equivalent of E. It's similar to pi. If you hit pi in your calculator, you guys get that 3.1415, right? That irrational number. E is the same way. There's a button on your calculator. It says e to the x. It's on the ln button. But it is an irrational number that is programmed in your calculator. You cannot do this in your head or anything. It's called the natural exponential function. It's on the same button that says ln, which is the natural log. Right? These are inverses of each other. But in e to the x function, e to the x, your exponent is still a variable. This is still an exponential function. It has all the same characteristics that a normal exponential does. This is just a specific one because it has a base of e, which is always 2.718281828. This is where e comes from. But this is where this is how e is derived. Similar to, you guys wonder how pi came about, right? Circumference equals pi times diameter, correct? So if you divide both sides by diameter, you get pi equals circumference divided by diameter. I don't know if any of you guys know this, but any circle, biggest circle you can find in the world, smallest circle you can find in the world. If you measure the circumference, which is the distance around, and divide it by the diameter, which is the distance from one side to the other through the middle, you'll get something really close to 3.14. No matter how big or how small the circle is. There's a ratio, there's a relationship between the circumference and the diameter of a circle. But I digress. All right, I'm going to go through these a little quicker than the latter ones because I want to make sure that we got this. But guys, if you're evaluating, that just means plug in, right? So if you're going to evaluate this would be e to the x would be 4.2. In your calculator, you would literally hit second ln, and the e comes up, and then you have 4.2. It's really important that you guys practice this because especially when we do the next part, when we're talking about interest, it's very tricky plugging in the calculator. And if you make one little mistake with a parenthesis or something like that, your whole problem's wrong. Some calculators require you to put parentheses and exponents, some don't. So we just need to practice with this. But when you do this, you get 66.686, because here it says round to 3. The second one, if you're going to evaluate, you have 125e, and then it's to the 0.05 times 30. Now, some people's calculators, as soon as you hit second e, it just jumps up to the exponent, so you don't need parentheses. Some people's calculators doesn't just jump up and you have to use parentheses. So you need to know what your calculator does and doesn't do. You evaluate this. What'd you guys get? 125. Hit second ln, and then in the parenthesis you have 0.05 times 30. What do we get? 560 point, what was it? Well, it's 3 decimal places, so 211. Okay, perfect. Now, when we go to do the interest problems in a second, if you're not getting those answers, you guys need to let me know. Because we got to troubleshoot and check what's going on with our calculators. All right, moving on. I'm not super concerned right now with you guys can make a table of values and plug in plot points. I'm not crazy concerned about that. What I do want you to be able to do is understand this is an exponential function. Looking at this, how do you know this is an exponential function? Where is the variable? In the exponent, okay? An exponential function has a variable in the exponent. So my domain for this exponential function, because you're going to be asked these questions, is negative infinity to positive infinity. An exponential function is going to have a horizontal asymptote that goes hand in hand with its range. You guys can tell me both of those pieces of information just by looking at this equation. Your horizontal asymptote is whatever the vertical shift is. Where is this graph moved up or down? What are you adding or subtracting to 4 times e to the x plus 2? Nothing. So how do you write my horizontal asymptote is 0? You guys just took a test on horizontal asymptotes. Is that y equals or x equals? So it's y equals 0. If the number there was minus 1, it'd be y equals negative 1. If the number was plus 7, it'd be y equals plus 7. Now you guys can tell me the range, because your range is based upon the horizontal asymptote. It's that line. Horizontally, your function's going to get real close to, but not touch. It's either going to be negative infinity to 0 or 0 to infinity. So just by looking at your function, you can tell me where this graph exists. Is this a growth or a decay? Think about the base. What's the base? E? What's the value of E? 2 point something, right? So is that bigger than 1 or less than 1? Bigger. Okay, so it's a growth. Is there anything that is reflecting this function over the x-axis that would make it flip over? No. If you had a negative out in front here, then it would flip over the x-axis. But this is a positive exponential function. It's going to look something like this. I don't know exactly what it's going to look like. I'd have to plug in a table of values. But I know from my equation it's positive. It's a growth. It's going to go something like that. So what is your range for this function? 0 to what? Infinity. Does it include 0? Does it include 0? Is your function ever going to touch that horizontal asymptote? No, so it does not include. Does this have an x-intercept? Why not? What does the graph get really, really, really close to but not touch? The x-axis, the 0. So your x-intercept here would be none. How would you guys find the y-intercept? You'd plug in 0 for x. Can you do that in your head? No. You guys know what E. So you would just plug this in to get the y-intercept. It's like 29 or something like that. You guys should be, you plug in 0 and you get what, 29.5? Okay. All of these things you should be able to do because we did all of this with finding x and y intercepts on quadratics. You had to factor, you set equal to 0. You should be able to determine these things by looking at the function. What's going on here? What does this plus 2 do? Where does that shift my graph? What does the plus 2 in the exponent do? It shifts it to the left too. Good. Anything in the exponent moves left and right. It's the opposite of what you think. Very good. What does this 4 in the front do? It's a vertical what? Stretch. Good. It's going to make it taller. That's why the the y-intercept is at 0.29.5. If that was 1/4, it would stretch or shrink it, compress it, would smush it down. Right? You guys need to be able to look at this and do those sorts of things. We're going to practice this a bunch, but it's got to be automatic. All right, this next part, compound interest. Miss Murphy and I were just talking at lunch. She said she talks about compound interest in economics. So here we go. All right, these two formulas you guys have to know. There's going to be, like I said, 2 parts of your quiz. The first part is going to be without a calculator. You're going to have to graph an exponential, solve some one-to-ones, graph a log. That's what we're going to do tomorrow. Then you're going to turn that in. And the second part is, here is a problem. Tell me the 2 answers. If you know these 2 formulas, it'll take you about 2.5 minutes to do. If you don't know the 2 formulas, you could stare at the paper for 25 minutes and not know what to do. Very important that you guys learn these formulas. You should have seen these in Algebra 2. If you didn't, okay, fine. Here you go. But this says compound interest versus continuous compound interest. T. Guys, T, this little value right here, is always going to be the time given to you in years. A is the balance of the account. That's generally 98% of the time, that's what we're looking for. P is your principal. It's the amount of money you start off with. And what does this say right here? R is your interest rate, okay? But it's in what? Decimal form. Guys, I know you guys have seen a million car ads and it says 5.99% APR, right? If I say 5.99 annual percentage rate, is that a decimal? No, God bless you. Is there a decimal in it? Yes, but this is a percentage. How do you change a percent to a decimal? You have to go to the left 2 places. So this is really 0.0599. There is a huge difference between those 2 numbers, especially when you calculate things. If you do not change your interest rate to a decimal, even if there's a decimal in it, you will get your answer egregiously incorrect. Very, very important. All right, now if you notice, there's one letter in that first formula I did not mention, and what was that? The N. N in the formula, N, is how interest is compounded. And you guys are like, oh my gosh, seriously? What does that even mean? Guys, it's not, this is this basic vocabulary. Here's our math sadlier for you. N. If I say to you, and remember, everything is based on years. If I say to you that interest is compounded yearly, how often is yearly? If you have to go see your dentist, no, you can't see your dentist. If you go see the doctor for a physical yearly, how often do you go? Once a year. Yep. So if something is compounded yearly, your N value is 1. How about if you had semi-annually? Twice a year. Good. What about if I said quarterly? 4 times. Somebody was like, I don't know how many quarters are in a year. How many quarters are in $1? 4. If you cut something into quarters, it's always 4 pieces. What about if I said monthly? Okay, the number you would use is 12. What about if I said weekly? 52. There's 52 weeks in a year. And then what about if I said daily? 365. Don't worry about that point, whatever. These terms you guys have to know, because I could give everyone in here the same principal amount of interest, the same principal amount that you plug in, the same interest rate, the same amount of time, And I could have 1, 2, 3, 4, 5, 6 different ways that the interest is compounded, 6 different answers. You have to know what those words mean. All right, and then lastly, we're going to talk about if it says it's compounded continuously. Continuous goes with our friend APERT. Continuous is our friend APERT. It's principal times e to the rate times time. There's no n value. There's no compounded quarterly, yearly. Compounded continuously means, APERT. And it's principal, rate, and time with the e. So let's do these. Let's do this example, and we're going to do it 4 ways. We're going to get 4 different answers using the same information. Now, if you don't know the formula, you don't remember it from Algebra 2, you're kind of like, I can't. So then write it down. It's principal times 1 plus r divided by n raised to the n times t. Now, I'm going to put my r and n in a parenthesis. Check, make sure, is that the right formula? Did we write it correctly? Okay, so now let's go through. Let's identify what they gave us. This says, find the accumulated value of an investment of $15,000. What is $15,000? What letter? P, my principal. The amount that I started off with was $15,000, okay? For how many years? 2. What information is that? T. T equals 2. What else do they tell me? My interest rate, my R, is 3.2%, but I know that that's not the number I'm putting in my calculator. The number in my calculator is going to be 0.032. Good. Cross that out so you don't get confused. And then the last letter I need is N. Well, in A, B, and C, they gave me different N values. So for A, I'm going to use N equals how much? Semi-annually. 2. For quarterly, N equals how much? 4. For monthly, N equals how much? 12. And then the last one says continuously. What do I think of when I see continuous? APERT. Our friend APERT. Good. So now we're going to do this problem 4 different ways. You have ones on WebAssign like this. It's very simple, guys. I'm going to give you a paper, and it's going to give you all this information and ask you to do 2 of these. So you either know the formula or you don't. So if we do A, this is what I would be looking for. I need to see exactly what you put in your calculator. If all you do is give me an answer, I'm not giving you credit. I need to see, okay, it's $15,000 that we put in. And then it's 1 plus, what is the rate? 0.032 divided by, in letter A, what is my N value? 2. And then I raise that to the N times T, so 2 times 2. I need to see that for you to get credit for a few reasons. Some of you will plug that in your calculator and come out with some ridiculous answer because you forgot a parenthesis or something like that. If you show me that you knew what to put into the calculator, but then just did something funny with your fingers, okay, I can give you some credit for that. But if you show me that you don't know what to put in the calculator, or you just get an answer and I don't see how you got it, you're not getting credit. So make sure you guys show me. Now, everybody that has a calculator, you need to practice this. You have to tell your calculator to do this division first, then add the 1, then raise it to the 4th power, then times it by the 15,000. The way that you do that, guys, you've got to have this double parenthesis here. So you would type in 15,000 parenthesis 1 plus parenthesis. Then you have 0.032 divided by 2. Close that parenthesis. Then you have to close the whole parenthesis. Does that make sense? You got that double parenthesis there. And this is why we got to practice. So close, close, and then raise it. Do you have to say to the 2 times 2 power? No. I know you guys know 2 times 2 is 4. You can put 4. It doesn't matter. But when you do that in your calculator, what do you guys get?
15,000.
$15,983. I love it. And 28 or 29 cents. Perfect. Now, guys, we're talking about money. It may not say round to 2 decimal places, but don't give me 17 decimal places. We're talking about money. Round to 2. Use your brains. Now, I want you to notice something because some of you will, if you didn't get that, and you don't want to tell me, that's fine. Check around with somebody or say, hey, can you show me how to do it later? But notice the original we started off with was 15,000. And after we compounded it by whatever interest rate, certain amount of time, look how much that number changed. About $983. Is that a huge jump? No. When you guys do these problems, the initial investment and then what you end up with should not be a huge difference. What I mean, sure. What I mean is, if you didn't change your interest rate, you kept it as 3.2 and you plug this in, your number would be a lot bigger. Right? If you start off with an initial investment of 15,000, you hit enter in your calculator and it tells you calculator overflow. Don't tell me there's something wrong with your calculator or that I have the problem wrong. You did something wrong in your calculator. You should not come out with 1.73 times 10 to the 29th power, right? That's not a conceivable answer. So just check. If you get something like that, clear your calculator out and try again. Let's look at B. What's the only thing that changes in B? The end value. So I still have $15,000. I still have my 1 plus. My rate is still 0.032. But now I'm compounding quarterly. So my 2 becomes a 4. And then I raise that to the 4 times 2 power, or 2 times 4, however you want to say it. So let's practice that in our calculator. 15,000. Parenthesis, 1 plus, parenthesis, 0.032 divided by 4, close, close, and we're going to raise it to the 8th power. What'd you guys get? 15,000. 987. I love it. So from what? 31 cents. Okay, look at the difference between 15,983 and 15,987. It's $4. Everybody see that? It's not going to be a ginormous jump between these different answers. You should be able to check yourself and say, okay, I did something wrong here. This number shouldn't have gone from this to this. Should your number ever go down? No. You're always adding here. If you have a minus sign in the middle, that's another thing that you could say, wait a second, how did I start off with 20 grand and I invested it, I'm making money and my money went down, right? That means that maybe there's a sign wrong in your formula. So look at C, I have 15,000, well that doesn't look like. And now I have 1 plus, my interest rate is still the same, but I'm now compounding monthly, right? Yeah, so my n is 12, and then I'm going to raise this to the 2 times 12 power, or 24, however you want to write it. Same setup. 15,000, 1 plus, parenthesis, 0.032 divided by 12, close, close, and then you're going to raise that to the 24th power. What do we get? 15,990.02 cents. Okay, good. Again, not a major jump. Now, if you guys notice, there's not a major jump between these two answers, so you need to be pretty exact. If you're off a penny or two when you're rounding here, not that big of a deal. You know, you put 03 and 02, whatever. That's not that big of a deal, but you need to be within the nearest cent or so. All right, let's look at the last one, and then we're done. The last one says continuous. What does continuous mean? A perts. A perts. That means I take my principal, which is 15,000, and I hit E, and I raise that to the 0.032 times 2. Again, the The reason that I'm doing this with you step by step by step by step, I know you guys can handle this, but some of us are not super familiar with our calculators. Some of your calculators require parentheses around exponents, some don't. So you just need to make sure you know what is expected of yours. You will absolutely have to have a calculator for your test. For your quiz, I mean, you could possibly pass it, but you won't get these problems 100% correct if you don't have a calculator, because you can't do this in your head or on paper. So if you don't have one, try to figure out where you can borrow one from. 0.032 times 0.2. What'd you guys get?
15,991.
991, 39 cents. Compare all four of these numbers. What is the difference between your first and your last? $8, $9, not a big deal. Not a big difference. You should not go from 15,000 as your initial investment to 250 million. I will not give you any numbers that grow that quickly. Yes, sir.
When is this used in real world?
Compound interest used a lot.
I mean, yeah, but for like which situation? Give me an example.
Like in a bank.
Really, they give you an interest rate?
Yeah, you can invest money, and then like my husband watches the rates on everything. He puts different stuff into different places.
For the stocks.
Mm-hmm.